Okay, so we are going through 5.4, solving compound inequalities, and I'm going to put day 1 and day 2 in this exact same video. So you'll be able to look at both of them. So compound inequalities, basically what this means is we are going to be doing more than one inequality on one number line. So everything else is the same, except now we're just doing more than one and we're putting them both on the same number line. The only thing that you need to know that's kind of brand new is that a compound inequality consists of two distinct inequalities. It just means two different inequalities joined by the word and or the word or. So basically I could say you're picking a number that's less than 5 and greater than 2. Or you could say I'm picking a number that's maybe greater than 5 or less than -3. And so that's what we're going to be doing on this one. It'll make more sense as we start to go through these. So number 1, all real numbers that are greater than -2 and less than 6. So greater than -2. If I'm doing greater than -2, what that means to me is it's going to be an open circle because it's not equal to -2. And greater than would mean it's pointing up in that direction. I'm going to do a small arrow for now because I'm just going to show you that we're not actually finished with it yet. And then also it says and it needs to be less than 6. So here's 6. We need to be less than 6. That's going to be this way. And I didn't fill in my circle because it doesn't say equal to 6. It just says less than 6. And over here, on the other one, it said greater than -2. Now, if you see those two arrows pointing together like that, that means it's going to cover all of these numbers. For example, if I just picked a number at random here, let's say I pick, I'm going to adjust this quick. Let's say I pick number 2. Is number 2 both greater than -2 and less than 6? Yes, it is. So what I'm going to do is I'm going to connect my arrows to form one giant line. My line is between those two circles. Okay, for the next one, it says all real numbers that are less than 0. Okay, well, less than 0 would be this way. And then it says or greater than or equal to 5. Well, greater than or equal to means I'm going to have a filled in circle, but then greater than 5 means my arrow is actually pointing outward the other way. So obviously these two arrows are never going to meet. And since it's an or problem, you only have to satisfy one of these two things. So for example, if I picked like 10 as my number, it doesn't satisfy the first one. It's not less than 0, right? But it is greater than or equal to 5, so it makes it true. So these or statements only have to satisfy one of the two inequalities. And statements have to satisfy both. The number that you pick has to satisfy both. So all or statements are going to look like we have here with the two arrows pointing outward. That's going to be true for every single or statement. And every single and statement is going to look like this with the two lines meeting. So this is an and. No, you can't read that. That's okay. And that's an or. Okay, so let's go ahead and start the first one. It says graph the compound inequality. Well, on this one, I don't see the word or. Like I see on number 4, I see the word or over there. This one is definitely going to be an and problem because x has to be true for both of these things. It's right in between them, so it has to be true for both. So to solve it, oh, actually it is solved. X is by itself. So it is solved. I just have to graph it now. So I'm going to put a point at -4. I'm going to make it an open circle because there's no equal sign attached to that. But there is an equal sign there. So that's going to be a closed circle at 1. I need all of the points directly between them because this is an and problem. And it's going to end up looking like this with a line between them. So I can actually just connect these with a line just like this. And we're done with that one. The next one is an or problem. X is by itself and x is by itself, so we're good. Or problems are pretty easy because you're doing them separately. You'll do that one first, so x is less than -2. That's going to be an open circle. X is less than means I'm pointing to the left. X is greater than or equal to 1. That means I'm filling in my circle and pointing it that way. X is greater than or equal to 1. And we're done. Well, again, ORs point away from each other and points into each other and creates one big line in between. Okay, next ones. Number 5. Now on this one, if I'm solving, I got to realize here, I don't have y by itself yet. So now, just like before, this is how I say it to my students. Just like before, we would add 4 to both sides. Now we have 3 sides. We have a side there, we have a side here, and a side there. So on this one, I'm going to add 4 to all 3 sides. Just like that. So negative 2 plus 4 is 2. Keep my inequality symbol the same. Since we're not dividing or multiplying by a negative, it stays the same. These cancel out. We're left with y. Bring down my symbol and keep it the same. And 14 plus 4 is 18. So this looks like it's going to be an AND problem. So at 2, it's an open circle. At 18, it's an open circle. And since it's an AND problem, we can connect our points with a line. That means all of the points in between, so anywhere in here, any of these points, if you plug it in for y, that would make it a true statement. Number 6, same idea here. We're adding 4 to both sides. So negative 3 plus 4 is 1. Inequality symbol. Cross those out, M, put my other inequality symbol there. Notice how I'm keeping them the same as how they were started. That one had an equal sign, the other one doesn't, so I'm not putting an equal sign on that other one. And then we should have a positive 3 over there. So fill in my circle here. This is an AND problem because we don't have the word OR in there. And at 3, I'm going to have an open circle because there's no equal sign. And I can just connect those, just like that. We're done. Moving on. This one looks a little bit more tricky. We're going to have to do multiple steps here. So first, I'm going to add 2 to both sides. Or I guess I should say all 3 sides. Negative 14 plus 2 is negative 12. Cross those out. Keeping my symbols the same. This would be a negative 2. Now I have to divide both sides by 2. Or I should say all 3 sides because there's 3 of them that we have to do here. So negative 12 divided by 2 is negative 6. Keeping my sign the same. X, keep my sign the same. Negative 1. So somewhere between negative 6, that's going to be a closed circle, and negative 1, that's an open circle, we can connect those to make our compound inequality. On to the next one over here. Same idea here, so I'm going to go a little bit quicker. Plus 1, plus 1, plus 1. Negative 10. 2x. Negative 4. Divide by 2, divide by 2, divide by 2. I got negative 5. Oops, no equal sign on that one. X is going to be by itself because those cancel out. And negative 2. So in between negative 5, which is an open circle, and negative 2 is a closed circle because that has an equal sign on it. It's an AND problem, so those can be connected. All right, now we have an OR problem. So again, we're just solving these separately. These are separate inequalities. If you want to draw a line right down the middle and do them separate, that's a good way to think about it. So minus 2, 3t, keeping the sign the same, negative 9, divide by 3, divide by 3, we get t is less than negative 3. Over here, we're going to minus 5 on both sides. We'll get 2t negative 4. Divide by 2 on both sides. So put an open circle at negative 3. and a open circle at -2. And it says for the -3, t is less than, so we got to have our arrow going that way. On this one it says t is greater than, so our arrow's going the other way. They're going opposite each other, just like every OR problem should be. Again, going real quick here on this one since we just did one like it. -7 for both sides, we get h, because those cancel out. Keep that the same. This will be a 1. On this one, we're going to add 6. Just like that. Open circle at 1. I don't even have a 1 on here, but I'll just do that. And then 4. Just like that. So then h is less than 1, so I got to point it this way. H is greater than 4, we're going to point it that way. Number 11, compound inequality. Just by looking at this, I can see it's an AND problem, and how all of the AND problems have been set up. If I can just come up here and erase this real quick. This is how my AND problems are set up. So, on one side I'll need that -6, and I usually put the small number on the left. Actually, every time I put the small number on the left, put the bigger number on the right. There's a 1. Put my x in the middle. And then I always have my inequality symbols facing the same way. So, basically, 1 is the biggest number, so all of my inequality symbols should be facing that. If you think about them like alligators, both alligators want to bite that 1. So we're putting them both there. Then we just got to worry about equal sign. Well, which one has the equal sign? The one that's on the -6, because it's a closed circle. So that's it. We're done. Same thing down here. Oh, actually, no, it's not the same thing. This is an OR problem, right? Because they're pointing opposite directions. So on this one, we're going to have 2 different ones. So it's going to be x and -2. And then on the other side, we're going to have x and 6. And I want to make sure that my x comes first. So on this one, we've done problems like this before because we've done inequalities if you just covered up this side of the screen. Right? If you covered that up and just did this by itself, you should be able to do that by now. If not, you can go back and look at, I think 5.2 has it. So now I'm going to say, okay, well, it looks like my arrow is pointing to the left, so that would be the numbers that are less than -2. So x has to be less than -2, and that's how you would write that. It's also equal to because it's filled in. On the other side, we're looking at numbers that are greater than 6. So numbers that are greater than 6 are going to look like this. X would be greater than 6. It's not equal to because it's not filled in. Okay, now we're going to look at 5.4 day 2. 5.4 day 2 is the exact same. It's just going to give us a little bit more of some tricky questions. So, starting here with number 1, if I add 4 to both sides, oh, I'm going to zoom in actually. If I add 4 to all 3 sides, I should say. Okay, so now we've got -2 plus 4. That would be a +2, keeping my sign the same. 3y, these cancel out. And 18. Now I can divide by 3. So then we would have 2/3. Keep my sign the same. We would have those cancel out. We'll just have a y there. And then over here, we've got 18 divided by 3, which is 6. So 2/3 is going to be located where? Well, it's between 0 and 1. So 2/3, I'm going to guess it's closer to 1 with an open circle. And then 6, I can find that one pretty easily. This is an AND problem, so we'll connect them there, and we're done with the first one. Number 2, we are subtracting 2 on both sides. So 3t, those cancel out, keeping that the same. This is a -9, divide by 3, divide by 3, t, is less than negative 3. Did we already do this one? I felt like we did. Maybe not. Okay, never mind. I thought we did. I thought we did one similar to this. Okay, anyway, subtract 5 from both sides. So if I do that, I've got those canceled out. Negative 4t is less than, so 1 minus 5 would be a negative 4. Next step, divide both sides by negative 4. And with that, we've got a special rule. We need to flip our signs on this one. Need to flip our signs because it's dividing by a negative. So those negatives cancel out. We're just left with a t. And these also kind of cancel out, but negative 4 divided by negative 4 is just a 1. So now if I come down to graph it, 1 is going to be an open circle. Negative 3 is also going to be an open circle. And since this is an OR problem, I don't even really need to look at them. I know that they're going to be pointing out. Number 3, we're getting a little bit more tricky here. I'm going to have to multiply all 3 sides by 9 to get that 9 out of the bottom. If you recall, we've got invisible parentheses up top, so we can't do anything up there until we get rid of this 9 out of the bottom. So if I multiply the front by 9, and I multiply the back by 9, and I don't really have enough room to multiply the middle by 9, but I know that it's going to just cancel this one out, so I'm just going to cross it out. Let's rewrite this now. So 9 times negative 3, that's 27, negative 27. There's my symbol. 6 minus q, keep my symbol the same. 3 times 9 is positive 27. Okay, now we have to subtract 6. Subtract 6, subtract 6, subtract 6. So negative 27 minus another 6 would be a negative 33, I believe. Okay, keep my sign the same. 6 minus 6 cancels out. We're left with a negative q, keeping my symbol the same, and 21. Now we have to divide by negative 1 on all 3 sides. If I'm dividing by a negative on all 3 sides throughout the entire equation, I'm actually going to have to flip both signs. That's a big thing to look out for here. Negative 1's being divided. So we're going to flip our signs. I'm going to flip mine right away, just so I don't forget. Negative 33 divided by negative 1 is actually a positive 33. The negatives cancel out here, and we're just left with q. And then 21 divided by negative 1 is a negative 21. Now, I cannot graph this yet until I get my lowest number on the left side, and this is always the tricky part. My lowest number here is negative 21. My 33 is my bigger number. Q is still in the middle. If I flip those around, I also have to flip my signs around. So it's going to have to go this way. Now I can graph. So there's a lot of numbers in between here. I'm just going to do my negative 21 and my 33 up there. You could figure out the best way to graph that. I just don't want to waste a bunch of time doing that right now while I've got you. This is going to be a closed circle. This is going to be a closed circle. It's an AND problem, so we're going to connect them. Next one. This is an important problem for future story problems, but we need to know how to do it before we can get into those story problems. So the first thing I look at, and when I see this, I could do 2 things right off the bat. I could either get rid of this 3 out of the bottom because we've got parentheses up top, or I could say, well, I do have parentheses on top, but I should combine the 20 and the 11 first to make 31. So I'm actually going to do that first. So 15 is less than or equal to, I'm going to make that a 21 plus k, that's a k, divided by 3 is less than or equal to 19. Now, I can multiply both sides by 3 since I have my hidden parentheses up top. So if I multiply both sides by 3, this will be multiplied by a 3, this will be multiplied by a 3, the middle will also be multiplied by a 3, but I'm just going to cross it out because they cancel out anyway. So this would be 45 on this side, less than or equal to 21 plus k, less than or equal to 19 plus 3 times 3 is, what is it? 757? I believe that's right. Hopefully I'm right. Now we can subtract 21, subtract 21, subtract 21. So 45 minus 21 would be 24. These cancel out. I'm left with a k. 57 minus 21 would be 36. Then again on my graph, I'll find 24 and 36, and I'll let you guys fill in the rest of those, make sure that they're evenly spaced out. But I see 2 filled in circles. That has a line connecting them because it's an and problem. And that's all. That's it. Let me know if you have any questions. Thanks for tuning in.